Hello, welcome back. I'm Marcus, and in this video, our topic is about rates of change. Okay, so let's begin. Problem number one. An alternating current, I amperes, is given by the equation I is equal to 10 sine 2 pi ft, where f is the frequency in hertz and t the time in seconds. Determine the rate of change of current when t is equal to 20 milliseconds, given that the frequency f is equal to 150 hertz. Okay, so solution, write equation. I is equal to 10 sine 2 pi ft. Okay. Determine the rate of change of current, meaning derivative of I with respect to time. Then differentiate this. So we have 10. Derivative of sine 2 pi ft is cosine 2 pi ft. Then derivative of 2 pi ft with respect to time is 2 pi f. There. So di over dt is equal to 10 times 2 pi f or 20 pi f times cosine 2 pi ft. Okay, what is di over dt when t is equal to 20 milliseconds and f is equal to 150 hertz? Okay, so lagay natin dito, no? When t is equal to 20 milliseconds and f is equal to 150, di over dt is equal to 20 pi times 150. Okay, cosine of 2 pi times f, 150 times the seconds, no? 20. And don't forget to put times 10 raised to minus 3. Okay. So di over dt is equal to, okay, let's use our calculator here. So we have 20 pi, okay, 20 pi times 150 there, times the cosine of, don't forget to change your mode here, no? Degrees, palitan muna natin. Shift mode. Lagay natin 4. Okay. Don't forget that, ha? So, cosine 2 pi. 2 pi times 150 by 20 times 10 raised to minus 3. There. So, equal to 3,000 pi. Mag-iiba ang sagot nyo kapag naka-degree. So, ito ay naka-radian. So, 2 pi. Radian yan, no? Okay. So, we have, what is the unit? The unit of current is ampere or A, and the unit of time is in seconds or S. So ampere per second. So this is your answer. Yes, madali lang. Okay, number 2. The length L meters of a certain metal rod at temperature theta degree C is given by the equation L is equal to 1 plus 0.00005 4 zeros theta plus 0.0000006 zeros for theta square. Determine the rate of change of length in millimeter per degree C when the temperature is A 100 degree C and B 400 degree C. Okay, for your solution here, write the equation L is equal to 1 plus 0.00005 theta plus 0.00000, okay, for theta square. Okay, so what is the derivative of L with respect to theta? So we have here derivative of 1 is 0, and derivative of this is 0.00005 plus this one is 0.0000 and 2 more. Okay, 4 times 2, we have here 8 and theta. Okay, so when when theta is 100 degree C, so dl over d theta, or the rate of change of length, is equal to 0.00005 plus 6 zeros there. So 8 times 100. Okay, so yun na. So let's compute this. So we have 0.0005 plus 6 zeros, 8 times 100 equals. Okay, so 1.3 times 10 to minus 4. But ang sabi dito is in millimeter, no? Mm or millimeter per degree C. So we have here convert this to millimeters. So we have 0.13. Okay, so dl over d theta is equal to 0.13 millimeter per degree C. This is your answer. Yes. Kulang ng N. Okay, so B. How about B? When theta is 400 degrees C, dl over d theta is... Okay, so ito na rin ang gamitin natin, but let's change 100 to 400 equals. So we have 3.7 or 0.37 millimeter. Yes, perfect natin to, no? Madali lang. Okay, number 3. The luminous intensity I, candelas of a lamp, is given by I is equal to 6 times 10 to minus 4 V square, where V is the voltage. Find A, the rate of change of luminous intensity with voltage when V is equal to 200 volts. And letter B, the voltage at which the light is increasing at the rate of 0.3 candelas per volt. Okay. Solution. The equation is I is equal to 6 times 10 raised to negative 4 V square. So letter A is the rate of change of luminous intensity with voltage. So that is dI over dV. Equals, differentiate this. We have 6 times 10 minus 4. Then this is 2V. Yes? Yes. Okay? When V is equal to 200 volts, what is the rate of change? So we have dI over dV, or the rate of change of luminous intensity with respect to voltage. Okay, we have 6 times 10 to minus 4 times 2 times 200. There. So we have dI over dV is equal to, so we have 6, okay, times 2 times 200, press equals, and the answer is 0.24 candela per volt. Okay, so this is letter A. How about letter B? In letter B, the voltage at which the light is increasing at the rate of 0.3 candelas per volt. So here, given yung dI over dV, and in question yung voltage. Okay, so same equation, we have dI over dV equals 6 times 10 raised to minus 4 times 2 times B. Again, ito yung in question, and this is 0.3. Given yan, given. Okay, so we have here 0.3 equals 6 times 10 to minus 4 times 2 times B, and solve for B. And V is equal to 0.3 over 6, okay, times 2. Okay, 250 volts. And this is your answer for letter B, and this is for A. Okay? There. Madali lang, no? Okay, how about number 4? The luminous intensity I, candelas of a lamp at varying voltage V, is given by the equation I is equal to 4 times 10 to minus 4 V square. Determine the voltage at which the light is increasing at a rate of 0.6 candelas per volt. Parehas lang to nung number 3B, no? Same lang din. So, here, solution is the equation is 4 by 10 minus 4 V square. Then dI over dV is equal to 4 times 10 raised to minus 4 times 2V. Okay, there. Then, dI over dV is given, that's 0.6, equal to 4 times 10 raised to minus 4 times 2 times B. So, what is V? Okay, what is B? So, we have 0.6. Gamitin natin ng iba. 4 by minus 4. Shift solve, gamitin natin, no? Kahit simple lang. Okay, 2 times alpha x. X is the V. Then shift, then solve. Okay, 750 volts. 750 volts. Yes, correct? See, 750. There. So this is your answer. Yep. Number 5. Okay, Newton's law of cooling is given by the equation theta is equal to theta sub O, e raised to minus kt, where the excess of temperature at 0 time is theta sub O degree C, and at time t seconds is theta degree C. Determine the rate of change of temperature after 40 seconds, given that theta sub O is 16 degrees C and K is equal to minus 0.03. Newton's law of cooling. Encounter nyo to sa differential equations and advanced engineering mathematics. Okay? So, yung Newton's law of cooling. Okay, solve na rin natin dito. We have here solution. The equation is theta is equal to theta sub O e raised to minus kt. Okay? And what is d theta with respect to time? So, we have here theta sub O. Derivative of this, e raised to minus kt times minus k. Correct? E to the u, du. Derivative of e to the u is equal to e to the u, du. There. So, recall lang, no? So, yan. Okay, so, given yung binigay na, no? The rate of change of temperature after 40 seconds, theta sub O is 16. So, we have your theta sub, d theta dt is equal to 16. Yes. Times e. Times e. Times e raised to minus k. And k is negative. So, negative, negative, minus, minus. So, we have your 0.03. Okay, pwedeng plus na lang niya ilagay niyo. Pinakita ko lang, no? Okay, lagyan na natin parenthesis. Yes. So, multiplied by, what is t? T is 40. No? Times 40. There. So, minus, or times, minus 0.03. Or positive, no? So, d theta over dt is equal to, so 16 by 0.03. Okay, times, okay, raised to 0.03 times 40 equals 1.59. 1.59 degrees C, no? Per second. Yan. Now, this is your answer. Okay? Yes. How about number 6? The voltage across the plates of a capacitor at any time t seconds is given by V equals V times e raised to minus t over CR, where V, C, and R are constants. Given V equals 300 volts, C is equal to 0.12 times 10 to minus 6 farad, and R is equal to 4 times 10 to the 6 ohms. Find A, the initial rate of change of voltage, and B, the rate of change of voltage after 0.5, no? 0.5 second. Okay, letter A muna, the initial. Okay, so dito, initial rate of change, meaning 0 second, no? Lagay natin, initial. There. So, the equation is V is equal to V times E raised to T over CR. Yeah, so differentiate dV or V with respect to time. So we have here V times E raised to T over CR, then the derivative of this, the du, and CR are constant. So we have minus 1 over CR. Or dt over dt is 1. So okay lang yan, no? So ganyan talaga. Negative 1 over CR. There. Okay, so T is 0, no? May mga values tayo given, 300, 0.12, and 4. So, let's write. So, dV over dt is equal to 300 times E. Okay? And initial, so 0, no? So, sulat na rin natin, minus 0 over CR. What is CR? 0.12 by 4. times 10 to minus 6 times 10 to the positive 6. So, 1 lang yan. So, hindi ko na sinulat dito. Okay. So, here, minus 1 over 0.12 by 4. Okay, e raised to 0 or 0 over any number, 0. Then e raised to 0 is 1. There. So, let's compute this. dv over dt is equal to, okay, so minus, we have 300 over 0.12 by 4 equals minus 625 unit in volts per seconds. Okay, so yan ang unit natin. Negative 625 volt per second. Okay, so letter B naman. B is rate of change of voltage after 0.5, no? So T equals 0.5 second naman. So same equation, but this time the T is 0.5. Yung 0 dito, magiging 0.5 na. Yes? Yes. So we have dB over dt equal to 300 times E raised to negative 0.5 over 0.12 by 4. Yes, times minus 1 over 0.12 by 4. Yes. So, bali yan ay minus 625 times E. Okay, so yun na lang din. Yes, ito na lang din, no? This is 300 or negative 300 over 0.12 by 4. So, multiply na lang natin to. Okay, yung answer na negative 625 by E, di ba? Oh, para tipid sa time. There. So, raised to, oops, anong nangyari? Times E, okay, raised to what? Okay, minus 5 or minus 0.5. 0.5 over 0.12 by 4. There. So, press equals minus 220.54. Okay. dB over dt is equal to minus 220. Yes, 0.54. Okay. Unit, volt per second. So, yun. At 0.5 seconds. So, that is the rate of change of voltage after 0.5 seconds. So, this is your answer. Yan. Okay. So, number 6 na. I mean 7. So, number 7, the displacement S, cm, of the end of a stiff spring at time t seconds is given by S equals a e raised to minus kt sine 2 pi ft. Determine the velocity of the end of the spring after 1 second if A equals 2, K equals 0.9, and F equals 5. Okay, andyan na lahat ang given. So, hindi na ito mahirap. The displacement S, centimeter, no? Displacement. So, ang hinanap natin is the velocity. When you differentiate the S or the displacement with respect to time, yun na yung velocity, no? Okay, so the equation is S is equal to A e raised to minus kt times sine 2 pi ft. So, when you differentiate this with respect to time, yan ay velocity na rin, no? So, velocity. When you differentiate the velocity with respect to time, yun naman ang acceleration. Or if you get the second derivative of ds over dt, acceleration din yun. No? Okay, so we have here ds over dt is equal to, so meron tayong two functions. So product of two functions. Okay, so recall, no? So derivative of uv with respect to x is equal to copy the first, then derivative of the second, then derivative, copy the second, then derivative of the first. Yan. There. So, product of two functions. Okay. So, copy yung first. So, we have here a e raised to minus kt, then derivative of sine 2 pi ft. So, we have cosine 2 pi ft. Then derivative of 2 pi ft with respect to t is 2 pi f. Okay? Di pa tapos? Ito pa, sunod. So, plus sine 2 pi ft, copy, no? Yung second. Then, derivative of the first function. So, we have a, a, then e raised to minus kt. Then, derivative of minus kt is minus k. Okay, so minus k. There. Yes. Ayusin lang natin. So, we have here ds over dt equals 2 pi, ito, 2 pi f, 2 pi f a e raised to minus kt. Okay? Then, cosine of 2 pi f t. Ilipat ko lang doon, no? Sa harap. Then, this one is minus k or a k, minus ak. Okay, negative ak e raised to minus kt sine 2 pi ft. Okay, then evaluate this. When t is 1 second, a is 2, k is 0.9, and f equals 5. So, yun lang. So, ds over dt is equal to 2 pi, f is 5, a is 2, then e raised to minus kt or minus 0.9 by time is 1. Okay, 1 sec, no? Then cosine of 2 pi times 5. Then t is 1 minus a is 2, k is 0.9. Then e raised to minus 0.9. Okay, times 1. Sine 2 pi. Then 5 times 1. Okay, merong sine 2 pi. Ano ito? Oho, 0 na yan. Okay, so ito na lang pala ang kukumputin natin. Yes. So let's use our magic Casio. Okay, so ds over dt is equal to. Okay, so let's use this one. So we have here, 2 pi. 2 pi times 2 times 5. So we have 10 times 2. So 20 pi. Okay, 20 pi. 20 pi. Times e. Okay, e raised to negative 0.9. There. Times cosine. Radian mode, ha? Radian mode. So, 2 pi or 10 pi? 10 pi. There. So, press equals 25.54. Sige, 25.54. 0 na to, no? Okay, 0. Okay. So, meron tayo, what is the unit? Velocity yan. So, we have centimeter per second, no? So, yan yung displacement natin. Or the rate of change, no? Or the velocity. Yan, 25.54. So, this is your answer. Okay, so there. How about number 8? The pressure P of the atmosphere at height h above ground level is given by the equation P equals P sub O e raised to minus h over c, where P sub O is the pressure at ground level and c is a constant. Determine the rate of change of pressure with height. So dP over dH. When P sub O is 1.013 times 10 to positive 5 pascals and C equals 6.05 times 10 to 4 at 1450 meters. Height yon, ano? Okay, so let's solve this. Solution. What is the equation? P equals P sub O e raised to minus H over C. Okay, so what is the rate of change of pressure with respect to height? So dP over dH. So we have here P sub O. Then this one, derivative of this is E raised to minus H over C. And the derivative of minus H over C with respect to H is negative 1 over C. Okay, so rewrite ko lang. So dP over dH is equal to minus P sub O over C times E raised to H over C. Okay na. Sige. So, lagay lang natin yung mga values, given values, no? So we have dp over dh is equal to minus po is 1.013 times 10 raised to 5. And C is 6.05 times 10 to positive 4. There. So we have E raised to minus H. Yon. Minus 1450 over C is yon. 6.05 times 10 raised to 4. Okay? So, dP over dH is equal to, okay, there, 1.013 raised to 10 raised to 5, okay, over 6.05, exponent is 4, multiplied by E, then raised to, ay mali, ulitin ko na lang. Okay, sige, ulit na lang. So, minus, kamali ako ng pindot eh. Sige, 1.03. Okay. Mahirap pag stylus gamit mo. Okay, 6.05. Okay, there. Then multiplied by E. Okay, alpha E. Okay, raise. Yun. Then fraction. Then minus 1450 over 6.05. Then raised to 4. Okay, press equals, and the answer is minus. Is it negative? Correct. So minus 1.6. How much? 634. Okay, 34. Or 35. Tama ba? Yeah, pwede na yan. 35. And the unit is in Pascal per meter. So height is in meter and the pressure in Pascal. So Pascals per meter. That's 1.635. So this is your answer. There. So madali lang, no? Perfect natin. Yes. So in the next video, application of derivatives pa rin, ano? Velocity and acceleration. So, see you there. Sige, bye-bye.